before we get started formally, I just wanted to give you a little explanation behind the word cloud behind me. When you all registered, you indicated what topics you were most interested in hearing about related to these topics today, and we did our best to try to coalesce them into some way, shape, or form, and I think you can see the variety of things that people are interested in learning about. We may not get to every single thing on here. I can guarantee you that carbohydrates, obesity, fat, sugar, childhood is going to get addressed, but we'll see how far and wide we can go. Our setup today is that we are going to start with one speaker. After the speaker, we'll have time for question and answer. We'll take a break, and then we'll come back and have our other two speakers again with time for question and answer. And then depending at the end, if there's still time, we'd love to be able to facilitate as much question and answer as possible. So our topic today is fats aren't the whole story. The future of obesity prevention, that's really our focus. And we're looking at it from a multi-generational aspect. I'm very excited to introduce our first speaker. Dr. Susan Bagby is a physician and nephrologist and professor of medicine and physiology pharmacology at the Oregon Health and Science University. Her academic medical career is focused on patient care in areas of hypertension and chronic kidney disease, teaching principles of medical pathophysiology and clinical practice to students and residents. She has received NIH and VA Merit Review funded research in mechanisms of developmental hypertension, served on national review groups for the American Heart Association, National Institute of Health, and National VA Career Development Program. She recently served as an invited participant at an NIH-wide science visioning process designed to focus on health disparities research. Her ongoing research centers on pathways of nutritional programming in early life as a cause of hypertension and kidney disease in adolescence and adulthood. Dr. Bagby currently serves as a founding member of the steering committee of the Bob and Charlie Moore Institute of Nutrition and Wellness at OHSU. She heads the Institute's community education and outreach effort, currently focused on developing and disseminating enrichment nutrition curricula for youth and young adults. Welcome, Susan. And while we're getting her slides up and running, just want to also remind those of you who are live streaming that we will be monitoring your questions digitally, and we will try to ask some of those as well as providing opportunities for folks here in the room. We'll do our best to get as many in as we possibly can.
Thank you so much, Deb.
And just as a reminder, the mic is for the production, but the amplification comes from our diaphragm and all that stuff. So.
And I'm delighted to be here. It's often difficult for me to project, so raise your hand if I get softer. This is the second year that we've done this, the Moore Institute and Deb's group at PCC, Food Nutrition. We are thrilled to do it and hope this is going to be ongoing. We are, of course, dedicated to the message of early life nutrition and how that impacts health down the line. And so the degree to which PCC's wonderful facilities magnify and disseminate that message is really powerful. So thanks, Deb. Okay, let's see if I can figure out how I think I'm going to use this. So, Science of Obesity, Fighting Fat with Fact. Here's what I'm going to try to do, roughly. A little bit about the obesity epidemic, which you all know about, and then focus on the biology of obesity, the fact that it really is a manifestation of a developmental processes that go on in early life. We're going to look at how both undernutrition and states of overnutrition in fetal or early life can program the development of chronic disease. I'm going to get you into some of those mechanisms of chronic disease. This, you'll see my pathophysiology background peeking out. And then I want to talk to you about how those things that are programmed can be passed down to future generations. And really, the fact that this is a crisis for the 21st century. So, the epidemic of obesity. You can see here a graph. I copied this, so it's not perfect. But these are the rates of obesity as a percent of the population. The top two bars are men and women in the U.S. The bottom two dashed bars are global. And you can see that, and really it's coming from about 1965, but mark 1975, and you can see over time the increase in the incidence of, really that's the prevalence of obesity. And then it's projected beyond 2014, when this was published, on out to levels that you can see for the United States are around 40% plus. This has increased in a way that no one has ever seen, except in infectious and communicable diseases, and yet this is a non-communicable disease. So we were really caught shorthanded in terms of understanding this. So how did we get here? What's happened? I'm old, so I've lived through it, and things have changed dramatically in so many different ways. If you think about sort of the attitudes that have come across over that time on the way to the truth. The saturated fat is bad. We started with that. That was right. Unfortunately, that got twisted to say all fat is bad. And then that led to a frenzy, if you will, of low-fat diets and high carb. And even if you weren't trying to do high carb, if you're on a low total fat, you're going to do high carbs just to get enough to eat. That proved to be totally ineffectual in terms of reducing the risk, the cardiovascular risk that we were getting after. And then about that time, when fat looked bad, the sugar companies thought, oh, this is our chance, sugar's good. And as you all know, we're inundated still today with sugary products that we're fighting very hard to do something about. And I couldn't resist putting fruit juice sugar is better because that's what my daughter thought, no matter what I said. So one of my granddaughters literally got rotten teeth because fruit juice was considered good. It's an amazing story. Food culture has changed, portion sizes, processed food, eating out, food knowledge has declined. We've lost our food culture. And certainly the convenience culture has cut down on how many steps we take a day, cars, TVs, remote controls, online services. All of it contributes to our sedentary state. So that's how we got here. But up until about 1990, practicing medicine, I'm in the clinic, and people are coming in, and we begin to see this in the clinics, this increase in a group of diseases that we did not understand why this was happening. We had only two etiologies, if you will, of these chronic diseases. One, it's genetic, although that wasn't really very helpful and we couldn't do anything about it. And the other was the choices that people were making in terms of their diet and exercise. And of course, in that period of time, it was all your fault. It turned out to be wrong. And in fact, during that time, we were so impressed with this conglomeration of disease entities coming together in the same person that we made up a syndrome. We made up a new entity that we call Syndrome X. And ultimately, that's evolved to what we now know as metabolic syndrome. And that consists of visceral or intra-abdominal obesity specifically, not generalized, high blood pressure, increase in your triglycerides, reduction in your good HDL cholesterol, and impaired fasting glucose. All of these things were happening together. And then in 1990, there was a paradigm shift. And that came from somebody many of you here knew and love. His name was Professor David Barker. He was part-time at OHSU for the last 10 years of his life, and it was a wonderful treat for us to work with him. What he did over a period of close to 20 years is learn and teach us that environments that you're exposed to in early life, in fact, can change your body, can alter your physiology, change your organ structure and the way your body expresses genes, and that can in fact program how you function in later life and increase your risk of chronic diseases. And those diseases that I'm going to talk about today are those that come under the metabolic syndrome category. So we had an old definition of obesity. It had to do with BMI, body mass index over 30. That was it. Now we see obesity as a late manifestation of a progressive, multi-system metabolic dysfunction. And it's initiated in early life. It's initiated by adverse environmental exposures, and it's defined by this excess in visceral or intra-abdominal obesity, and it is just one component of the metabolic syndrome. So we no longer see obesity as a standalone. So what is this process through which early environments program the body to behave differently in subsequent life course? Well, the concept is that it's a normal biologic process. We know that it is. It is particularly occurring in the developing organism. And I want to emphasize that the developmental years are not just the fetus, which is what we thought early in this field, but in fact, it's all the way through, at least to young adults, certainly including adolescents. Now, it's true that susceptibility is different across that range, but it certainly extends beyond the very early periods. We call it developmental programming. It happens without any change in the inherited genome, and that's called epigenetics. So it doesn't change the structure of the DNA sequence, but it changes the way genes are expressed. We know that the exposures that can do this, are known to do this, are nutrients, which is what we're going to talk about, but also stress. I know some of you are interested in that. Stress is a very important one. Oxygen, chemicals, and toxins in the environment are another big area of interest in causing developmental programming. And we are going to talk more about pathways, so changes in organ structure, if this is occurring in utero or in the early postnatal period when organs are still developing their structure. That's permanent if it occurs then. There's change in cell and organ function. We really don't know much about what is and isn't reversible in that setting. And there is, very importantly, a change in the regulatory systems of our body, the systems that respond to the environment. Those are our survival systems. And we'll talk a lot more about how that's changed and why that causes disease. The big picture point is that when you have developmental programming, it doesn't automatically lead to disease. It depends on what else happens. So it sets you up for vulnerability, and that is a positive note because we can then begin to understand what are the factors that will interact and amplify and lead to disease. So I want you to know, just as an aside, that we're talking about metabolic syndrome, and these are, again, are the things that fall under that heading, a very large list. But there are now, we know, many other entities which are increased or amplified risk by developmental processes: immunologic, musculoskeletal, very importantly mental and behavioral, and certain kinds of cancer. So I'm just going to look at a subset today. Now you have to get your head in gear. And it actually took me a number of years to really get this idea in my head. So what I'm showing you here is that the nutritional life of the egg, the human egg or ovum, is in fact transgenerational. So here, I'm going to look at the daughter here. Here's the daughter as a child, and here she is as a fetus in mother's womb. That fetus was derived from the ovum in mom's ovary, and that ovum was in fact formed when mom was a fetus in grandmother's womb. So if you think about the forces that could impact on this individual's daughter's health, it really goes all the way back to the grandmother, and we'll talk more about that. Now I want to emphasize, because if you don't live in this field, it can get confusing. So most of our data, and what I'll talk about first, come from the period of the individual pregnancy itself. Okay, what forces are acting here to cause developmental programming and affect the health? But we will then, a bit later, come to this earlier period, mom's lifelong nutritional exposures up to pregnancy, but before that pregnancy is initiated, also play a role in terms of the status of mom's body and ability to nurture a fetus. So that we now know is also important. So this is the biggest, well, maybe not the biggest picture, but this is an overview, and then we're going to dive down. So if you look at, we're looking along a life course from conception all the way through adulthood. And what we've learned is that the susceptibility to having this developmental programming occur is very much dependent on developmental stage. And it is greatest in utero, okay, so before birth. It's still very, very prominent in infancy and childhood. And then it balloons again in adolescence, particularly the adolescent brain. And that's something that's really being looked at closely. And we really don't know much about adulthood, but we know that at least certainly some severe exposures can have changes there. Right, so we're going to focus down on nutrition. And we're going to look at undernutrition as a programming force. And that can be from a low-protein diet or a low-calorie diet. That's what's been specifically studied. But there's a huge range of nutritional deficits out there that we haven't looked at. So it's very difficult to know in an individual person. And we know that that situation causes lower birth weight and an asymmetric form of growth restriction, which we'll talk about. And that leads to vulnerability. In that case, we typically see rapid childhood growth and leading most commonly to obesity metabolic syndrome in adults, at least, and starting in young adults. We also know now, and we learned this later as the obesity epidemic was coming up around us, that high-calorie malnutrition, which occurs in the situation of maternal obesity or maternal high-fat diet or gestational diabetes, and those situations provide excess nutrients to the fetus or to the child. And from the intrauterine standpoint, you get higher birth weights and a condition called macrosomia. We'll talk about that. In this case, you get rapid infant growth rather than rapid childhood growth. And again, interestingly, you get obesity metabolic syndrome. So the two ends of the spectrum, either one, can give us the same picture. And that tells you that something very stereotypic is going on in terms of the way the body is responding to these nutritional stresses. Now I want to focus first on undernutrition and give you a little bit of history about how this developed. This is a slide from David Barker. This was the very first inkling that the environment could cause chronic disease. In this case, they were looking at coronary artery disease. And they were looking in men in England and Wales who died from coronary heart disease in this 10-year block of time. And they saw this fascinating difference. It was really a socioeconomic health disparity in that in the red zones, there were high levels of coronary deaths, and compare that then to the green zones when it was very low. So no gradations. It was really high and really low. Now, David Barker was Renaissance educated, and he knew things that most people don't know. He knew that the land was very difficult here. Poor soil, poor food, and this is where the Industrial Revolution started. So it was a dirty, polluted industrial area, in contrast to the green areas where it was a very rich soil, and people might not be rich, but they had good food. So he asked the genius question. He asked, these men who are dying in 1968, 78, what was happening in those areas while they were being wombed, while they were developing in the womb? And to answer that, they didn't have longitudinal data, but they went back to neonatal mortality in those same areas, and what they showed was an identical pattern. So very high neonatal mortality in the red zones and low in the green zones. And that was the clue that something in the environment was causing coronary disease in later life. This just gives you a picture of what was happening in those red areas. Smokestacks. These are, oh, thank you. These, I have to tell you this is amazing. When I saw these, I thought they were container boxes. These were the housing for the workers in the factory. So it was a very dire kind of situation. So David Barker went on. He searched England and he searched the world for databases that would allow him to have longitudinal data connecting what happened at birth and what happened in later life. And ultimately, over time, it was shown worldwide that if you plot mortality or any given chronic disease, I'm showing you coronary disease and stroke, glucose intolerance, hypertension, that if you look at birth weight and relative risk of disease, the lower the birth weight, the higher the risk of disease. Right? And that is really important in terms of the nutritional health. And they're using birth weight as a surrogate for poor growth in the womb, which from these older cohorts, it was all undernutrition. So what does undernutrition do? It causes this asymmetric form of growth restriction. And this is a growth-restricted baby compared to a normal baby. They're thin because they lose more weight than height. They tend to protect their height. The fetal blood flow is redistributed. It goes more to the heart and the brain rather than to the lower organs. And so my favorite organ and others below the diaphragm are in fact more shortchanged in their growth than the heart and the brain. That's been called heart-brain sparing. And that gives you a reduced abdominal girth. And you may see reduced muscle mass and therefore low arm circumference. So this pattern is a more important indicator of poor growth than just the birth weight. And in fact, in retrospect, we wonder why the birth weight even served as well as it did. So this pattern can occur really at any birth weight. There are, as we said, gradients of susceptibility, and for each organ in utero and in early infancy, there are specific windows. So when the insult occurs, if it's a finite one, that will determine the outcome, depending on which organ, and determine which organ is affected. And just to show you, for example, that with the kidney, we know of two important areas, but it's all done before birth, and that's very important. The heart continues a little bit after birth. But again, that brain continues throughout in terms of being susceptible. Okay, now I want to talk to you a little bit about the pathophysiology. Right? And I know this looks daunting. It's not really. I'll take you through it. But I want to emphasize that both the malnutrition pathways or exposures, as well as stress, as well as toxins. They all work through epigenetic changes. We don't know very much about it yet. We don't know to what degree they're reversible yet, but that's thought to be a key point where everything is coming in, stimulating sensors, biologic sensors, and making epigenetic changes. And I'm going to talk about 4 different pathways that are activated by the epigenetic changes. The first one is, if it's occurring during organ development, a change in the organ structure and function. The second one is an increase in the stress reactivity systems. All right, these are fundamental survival systems that occur that were developed over evolution. This is the hypothalamic pituitary axis and cortisol, the sympathetic nervous system with epinephrine and norepinephrine. So that's a big one. There is an increase in the reactivity of immune and inflammatory systems. That's in every disease you look at. If you're reading the literature, inflammation comes up again and again. So in this programmed state, that response systems is heightened. And then there's energy dysregulation, and that one, of course, is very important for our discussions of obesity. We know that all of these various pathways are activated very long-lastingly. We don't know what's reversible. And they all feed in to 3 mechanisms of tissue injury: the inflammation, as I suggested, oxidative stress, and insulin resistance. Right? All of them feeding into that. And what you come out with is a susceptible, what I call a susceptible phenotype. You're vulnerable, but it's a phenotype. It's not a genotype, but it's long-lasting. And then depending on what you encounter later on in the environment, for example, a Western diet is considered a second hit. It's as if you need something happening out here to amplify these processes and have you develop outright disease. All right, so I'm going to talk a little bit about the specifics for altered organ structure and function, for these hyperactive survival system responses, and then show you a little bit how that interacts postnatally and contributes to disease. So for organ structure, I'm usually talking about the kidney here, so don't let me veer off into the kidney. A number of organs are critical to metabolic function and energy regulation, and many of you know that. Let me just remind you of that. So this shows a list of organs and the deficit that occurs under developmental undernutrition and what we can expect in terms of an outcome. So I'm going to look primarily at the highlights in yellow here. We know that with the pancreas, the key functional unit for insulin is the islet beta cell, and the numbers of those are decreased, and that means your maximum capacity for insulin secretion is reduced. That reduces your capacity to defend against diabetes, particularly if you're on a high sugar diet. Muscle mass is critically important. So we know that that's a major determinant of basal metabolic rate. That means calorie burning. If your muscle mass is reduced, as with undernutrition in early life, you have a reduced basal metabolic rate. It decreases your maximal exercise capacity, and in animals, it decreases your interest in moving. We haven't been able to confirm that in humans yet. It's going to be tough. It decreases your insulin sensitivity. Critically important things for how you handle energy and whether or not you're at risk for becoming obese. The kidney, see, I did it. The liver is critical with lipid and glucose metabolism, and the neural circuits are amazing. So in both ends of the nutrition spectrum, we know that neural circuits are structurally altered, the ones that are controlling appetite and stress reactions, the ones that are controlling the satiety center, and when our body tells us that we've had enough, that can be impaired. So a range of organs are influenced that have impact for metabolic function and energy regulation. All right, so now I want to turn to these hyperactive survival system responses and talk about two things. The first is the Thrifty phenotype, and show you how that feeds in to obesity metabolic syndrome, and a little bit about the stress system, the cortisol responses that are increased. They're hyperactive, and cortisol is elevated following developmental programming by nutrition. The Thrifty phenotype is one of the many things that David Barker gave us. He published this back in 2001 as a hypothesis. It's now been amply confirmed. The idea is, his idea was that the fetus is adapting to a nutrient deficit by permanently increasing energy utilization efficiency. So what is that? That means that in a growing organism, the amount of energy that you take in goes to a certain amount of tissue weight gained. Energy utilization efficiency means that for a given amount of calories, you have more weight gain. So those are biologic processes determining that adaptation. Increase in brain appetite promoting circuits. We talked about that. That's been shown now. These permanent adaptations, according to David's theory, was that you enhance tolerance to a sparse nutrient environment. So if you're born into the same environment that you were wombed in, if it's a low resource environment, then you'll be better able to tolerate that. Now, I question that from some later data. I don't think it's as simple as that, but it's easy to remember. Certainly, though, since the same thing happens with excess nutrition, clearly evolution did not or has not yet adapted us to that, because we see the same Thrifty phenotype with high-calorie malnutrition. Some examples. The rural to urban transition. This was first described in India, where rural residents, very sparse diets, thin people, thin animals, massive migration to the cities. Diets in the cities were very different, much more calories, much more refined carbohydrate and fat. And there is now, and has been for some years, an epidemic of obesity metabolic syndrome in the Indian cities. Another example is our U.S. immigrants coming from the third world. So if they've come from environments of sparse nutrients, often very healthy sparse nutrients, coming into our environment, and they are at very high risk of developing obesity metabolic syndrome. And I think I have time to tell you, I won't name the company, but I have to tell you another really terrible example, and that is that certain food companies are, as a deliberate decision, marketing in very rural communities in South America and Africa. And they go in with these little carts that hold all their sugary products. They identify mothers in those rural villages to be vendors, and they pay them a tad bit for that. And those mother vendors go door to door to their neighbors and sell these products. They educate their neighbors that these are healthy products, and they are sold at prices that are less than real food. So we now are seeing obesity in both the children and the mothers in that setting. So again, we have a lot working against us, but we won't give up. Okay, so think about the Thrifty phenotype. So you've had altered in your energy homeostasis, you're born, you have an increased appetite that's biologically embedded, you have this energy efficiency, you may have decreased locomotor activity, and let's say you're exposed to just regular food, not even good food. You will have accelerated growth because you're going to eat more relative to your body weight than you otherwise would, and you're going to that's you get accelerated growth, which means that maybe you started at a 15 percentile, and say when you were born, you're going to accelerate and you're going to go above that percentile. So let's say you go to 40%. Okay, you're still totally within the normal limits, but you've had rapid growth with crossing centiles. You may or may not see obesity accompanying that, and I think that depends greatly on the diet. You will increase your body mass to that higher level. And just to emphasize people who don't think in terms of percentiles or centiles, so when you look at children's height and weight, et cetera, you have charts, and they're showing you at a given age the span of the normal range of weight or height or BMI. And so this is the upper limit of normal, and this is the 10th or the 90th, and this is the 10th, not upper limit, but that's the 90th percentile, 10th percentile. So if you're born here and you undergo rapid growth, you're going to go to some degree above where you were born. And that's really all that means. Okay, now I want to bring in here what's happening with your hyperactive stress systems. Now cortisol does a lot of metabolic things that are not good when it's up on a chronic level. But what I want to emphasize today is that cortisol shifts fat from peripheral subcutaneous locations to central visceral locations, right? So that's part of this syndrome once you've been developmentally programmed. We'll come back to that. So let's talk about how these interact when you're in a postnatal world and you're faced with additional stressors that are now often referred to as second hits. So let's say that you have your energy alteration and you have your stress hyperreactivity with cortisol, and you're on a Western diet, high fat, specifically saturated fat, and high sugar, okay, if you're not paying attention. And you will, again, undergo accelerated growth, but now with all those calories and fat and sugar, you are very likely going to put on extra fat. And in the presence of the cortisol, it is more likely to be visceral fat. So you will be starting on your way to obesity metabolic syndrome in that setting in a Western diet. And you can also name psychosocial stresses would be considered a second hit in this setting that activate these processes and move you in the same direction. Now, just so you know, another of David Barker's contributions was the fact that just accelerated growth in the postnatal setting is a risk factor. And we know that from these are human studies. And just to give you an example, this is a typical graph that I can make, and you will see data, the same type of graph, whether it's in this case the prevalence of metabolic syndrome or obesity or hypertension, any of those elements look like this. And this shows birth weight. So here's the lowest birth weight and the highest birth weight. And this is what and in this particular case, these are adults, and this is what their BMI looked like, low, middle, and high in adulthood. And you can see that just with the birth weight issue, you have an increased risk of metabolic syndrome just if you're born small, even without changing your centiles growing up. But if you also increase your BMI total, you can see how markedly it goes up even with a normal birth weight, and look what happens with a low birth weight. So these are interacting and augmenting your risk of disease. Okay, let's look at what happens with high-calorie malnutrition. That's not a general term. That's sort of the Moore Institute's decision. We're going to call it high-calorie malnutrition. I actually like the term energy excess because it's energy excess to the fetus or the child that's the driving force. Again, we know that occurs in the setting of maternal obesity, maternal high-fat diet, or gestational diabetes. And we know that it causes a higher birth weight and a condition called macrosomia, at least typically. Now, I should, as a side, tell you that in obese pregnancies, there are complications that can actually cause growth restriction. But looking at the more typical side of it, we know that this so-called macrosomia can occur from these entities, and recently suggesting that it can occur just from hyperglycemia. And what we see is excess fat, we see a certain asymmetry of skeletal proportions, and we see that rapid infant growth that we talked about earlier. And again, this too can occur with a normal birth weight, but it's certainly more apt to occur at the high birth weight ranges. Now this is, to me, this is absolutely dramatic, this study. And it's dramatic, it's from the Generation R study, and it's really a baby birth cohort, pre-birth cohort, and it looks at the percent of metabolic syndrome. I want to emphasize that this is a modern cohort, right? So when we look back in the old cohorts, there wasn't any obesity. It just was not a factor in those early studies. So here we have maternal pre-pregnancy BMI, low, normal, overweight, or obese. And if you look at the percentage of metabolic syndrome, not the percentage of just obesity or just this or that, a clinical diagnosis of metabolic syndrome, which it takes at least 3 of those entities. And you look at across, beginning with overweight and then obese, and this is in 6-year-old children. 6-year-old children. So if you have maternal obesity, 22.4% of those children had overt clinically diagnosed metabolic syndrome. So that gives you some sense of the issue and the things that we need to deal with in order to interrupt this. Now I'm going to show you some information that comes from our own primate center out in Hillsborough, done by Kevin Grove and his amazing team, who study chronic high-fat diets in their monkeys. And these monkeys are kept on the diet for, continuously over years, and they're obese. They're also on a high-fat diet. And what they see are, just for example, in the liver, they see a hepatic lipotoxicity because of fat deposition. They see inflammation and oxidative stress, those key tissue damage entities, and they have fatty liver disease in the neonate. The brain, we've been talking about the brain is affected. In the fetal brain, there's inflammation. And again, those neural appetite circuits and reward centers are altered in ways that would promote increased ingestion. And they have some studies of behaviors that are absolutely dramatic. And there's a video that I still wish I had to show you, but I'll try to tell you. We know that the monkey offspring have increased appetite. They have a very intense preference for high-fat, sweet, salty foods. And I find that really important to know. Again, this is biologic. Right? This isn't a choice. This is something that's being biologically driven. They have accelerated infant growth rates, just as we said for humans. Early excess fat deposition. Early onset of puberty, another common finding. And they have increased anxiety in the females and aggression in the males. So additional behavioral entities. And so then to bring that concept back to the human setting, we have a study from 2012, again, a modern group, modern study, where we're looking at children of normal weight, overweight, or obese moms, and ADHD score and executive function index, which is the converse of what it looks like. So a high index means a low executive function. So what you can see is not with overweight, but with the obese setting, there's a distinct, significant increase in the ADHD score, and there is an increase in this index, which means reduced executive function. So again, when you think about, I'm a parent of an adopted ADHD kid, so I can tell you, it changes your life, it changes your kid's life. It's a very important kind of factor which changes your resilience, okay? And so I think that's something that is really important to keep in mind, and that's just one example. We do know that maternal obesity, at least until recently, has been increasing. I show you this slide because it breaks it down by neighborhood socioeconomic status, and that is certainly a major second hit factor in terms of risk of disease. And what you see is that at the highest socioeconomic levels, it's increasing, but at a much lesser rate than in the poor neighborhoods. And that's something that's been confirmed at in the CDC studies here. At OHSU, in 2010, I haven't been able to get updated data on this, 40% of the women who delivered at OHSU were obese. And this is not about delivery or maternal issues, it's just generic. But in this, the best I can find recently, the rates of obesity in whites, 38%, this is women, 46% in Mexican Americans, 57% in African Americans. So it really is a crisis. Okay, we've been looking at those conditions during pregnancy, just a little bit about the period prior to onset of a pregnancy and why that's important in terms of the health of future babies. So we know, in the setting of undernutrition, we know that if mom has experienced undernutrition in her early life, that her future fetus will have slower growth as in utero and as a child, and has an increased risk of hypertension and obesity. Now, it's not huge, and it's not as powerful as that first, as what it was for mom when she experienced undernutrition, but it is carrying into the next generation. We know that maternal undernutrition just prior to conception, in the fallopian tube, that mom's nutrition matters at that time as well. And in response to that, there's slowed fetal growth and postnatal hypertension. And then there's some metabolic features that we don't know exactly where they came from in the moms or when they happen, but they determine her ability to nurture a fetus. So our understanding just from that alone is that we can't just think about, to make healthy pregnancies, we can't just think about preconception in the OB-GYN definition, because their definition, I think the last I heard was 1 month before pregnancy, and usually it's not even before pregnancy. And yet we need to be thinking about mom's whole nutritional history if we want to have healthy pregnancies for future kids. Now, I told you earlier that the high-calorie malnutrition programming is typically associated with childhood onset of disease, and I showed you some data for that. So let me just have you think about that at another level, okay? So here we are, and I've changed my labels here. So now here's mom, and she has obesity, and she has a daughter. That daughter has a very high risk of having obesity as well, especially if there are no interventions. And because of what we just learned, we know that because of statistics that are most of you probably know about, we know that if you have obesity as a child, that you will commonly carry that into your reproductive years. And we know now that that means that she is likely to be obese when she has her children, and that her children will likely be programmed by that and have obesity as children, etc., etc., etc. So now we're talking about risk of obesity passed down across generations, successive generations, not just one, but and keeping the strength of it, because the strength of it is how mom's body is at the time of pregnancy. So I think that is really our 21st century crisis. And again, it totally emphasizes the fact that we can't think about the pregnancy after, in prevention. We can't think about the pregnancy after it's happened. We can't even think about it in the year before it's happened. Oh, that's better than nothing. If we really want to change, we're going to have to think about this whole transgenerational scenario, and we're going to have to start making really healthy little kids in elementary school and middle school and high school and college. That whole range. We've got to change the food culture, the food knowledge, and change the health, the nutritional health of those kids. Okay, now I have some hopeful facts, right? I told you we didn't know much about whether we can reverse epigenetics, but there's really powerful data that cardiorespiratory fitness really does reduce the cardiovascular risk of obesity independently of whether or not you lose weight. I think that's really important to know. It's something you can state with real confidence in terms of people who are struggling with this. Reduces the inflammatory markers, the abnormal lipids, the insulin sensitivity increases, muscle mass increases, longevity increases. So that's a very hopeful thing that we all need to use liberally. You're going to hear more about healthy diet, so I'm not going to say much except that there are certainly elements of healthy diet that are really going to make a difference in terms of cardiovascular risk. And I want to mention time, strangely. This process, this multi-system metabolic dysfunction, it's a process that occurs over time. So that gives us the opportunity to intervene. That also gives individuals the opportunity, okay, you may be overweight or obese, but, you haven't had it all your life. Make changes now, and it will make a difference. So I think that's another message that we really need to emphasize. This just is some of the data looking at the cardiorespiratory fitness. This is just a series of studies, and this over here favors high mortality. This happens to be, this is the obese individuals who were not fit. And this was using specific cardiorespiratory assessments to determine. You can't just decide whether or not you're fit. There's some specific definitions. But you can see that those that were unfit, on the whole, had an increased cardiovascular risk. But looking at obese individuals who were fit, that was, in most cases, reduced to near normal. So it is something we really want to think about. I think we talked about that. Okay, so this is things healthy food choices for that whole range, and this says women, but it needs to be everybody. I didn't talk about dads. We're learning more about dads' roles in this. They're not as typically as dramatic as the role for women, but they're going to be really important in toxic exposures because of the sensitivity of sperm to toxic exposures. So we're actively learning about that. I thought I had one more slide that I was going to show you, and I guess I didn't. So, thank you. More Institute, thanks you. And I'll take questions.
Thank you, Susan. We appreciate it. And we're going to take some time now for some questions. I'd like to open it up to the floor here, and then we'll take a few from our online participants too. Is there anyone here who'd like to get us started with a question? Comment? Come on over. The microphone is for the recording. And you will all have access to this session recorded. If you need to get a little volume boost, we'll be able to do that too. So,
I think looking at global health and the Thrifty phenotype is really interesting to me because of the fact that as we've transitioned away from having people die from starvation, and so we've had an increase of food availability, but if food availability is also increasing obesity based on the Thrifty phenotype, how are we thinking long term about how to maybe change that negative programming, or is there any research looking at that from a global perspective?
Okay, from a global perspective, I have to say I have to tell you that developmental origins research started outside the United States. And there are major centers in India, for example, in South America. So there's awareness there. And I would also, before answering your question, point out that there's still a pretty high rate of births, for example, that are afflicted by some aspect of undernutrition, be it prematurity or small for gestational age, et cetera. So we're not past that. And I think everybody is really trying to find interventions that work, but of course, since both of those limbs, in terms of the exposures, can cause obesity, metabolic syndrome, you have to sort of take them all into account. Can we change the food culture of the world? I don't know. I hope we can change it in the United States and then expand. The Gates Foundation is very much into this concept. We've tried to get their thinking more focused here. I think eventually we will. They have other priorities, like infectious disease and things, that are very important also. So I don't have a good answer, but people are looking very hard at that.
We have one online question. What are the epigenetic effects of men? I know you talked about this just a moment ago, but is there anything else that you would want to say?
If you mean, okay, so in terms of the epigenetic effects of programming, there are some sex differences, but in general, the epigenetic changes from these various exposures affect men and women. So that I can say. Now, if you're asking about, say, an exposure in a man and how that gets to the offspring, the key there is the only way that the male, at least that we know of, the only way that the male can contribute to the offspring traits is through either the sperm or the spermatic fluids. And so that's being looked at very carefully. We know that toxic exposures can cause mutation in sperm that can be transmitted. We know that the older the sperm are, the more spontaneous mutations that occur that can then be transmitted. There is fascinating evidence that can I remember that? I can't. There are other mechanisms that they're learning in terms of epigenetics in the sperm that can be expressed. But again, it's just in its infancy and a long way to go. That's a great question.
another question in this audience? I'm going to go to this side of the room now. Ask your question loudly so we can hear it.
Okay. I was curious about the increase of energy utilization when you were talking about like how the fetus adapts to nutrient deficits permanently. And because I'm also taking cell biology right now, I'm wondering, is the body still generating the same amount of ATP from nutrient molecules and then somehow doing more with the energy than a different body, or are they actually like producing more ATP molecules out of each
That's a great
nutrient
question.
input?
It's great. It's a great question no matter how you look at it. One thing you should know is that one of the areas that's being looked at very closely is mitochondria. There's actually some evidence, and these are from animal studies, that the ovum before pregnancy, while it's still an ovum, can undergo mitochondrial damage before the pregnancy even occurs, and that mitochondrial change can be transmitted. And it's shown up like in, I think, skeletal muscle and liver in the offspring. So mitochondria are a real focal point in terms of understanding how this works. But I would love to know the answer as to how they handle the energy. There is evidence, again, this is animal data, that the changes in energy metabolism are very long-lived, if not permanent. And that comes from evidence, and it goes back to, say, the U.S. Immigrants coming in and being at increased risk. There is evidence that in an animal study, that you can go 50 generations of exposure to a low-calorie diet or a low-protein diet, and then change to a normal diet. They took it down 2 generations, and that change, that energy efficiency persisted. Now that's animals. We don't have the data in humans, but it would suggest what we know in humans is that it also may be very long-lived. Thanks for a question. Great question.
Okay, so the next online question was, if you have gestational diabetes and have a high birth weight infant, but mom is healthy otherwise, does that give the infant the same risk for obesity as the mom with overnutrition?
Oh, so in the setting of maternal gestational diabetes, yes, that is considered one of the conditions which provides excess nutrients, excess energy to the fetus, and does cause the same thing, as we understand it, as maternal obesity. There are going to be some tweaks and differences, but overall it does carry an increased risk. It is not an absolute, but I would tell somebody who was in that situation is you want to be aware of that risk and be very particular about training. Your child's preferences occur very early, about modulating those toward a really healthy diet and not sugar and not saturated fat, and just take all the steps we know you can take to minimize that risk. And the other would be build in exercise. Yeah, good question.
Another question here in the audience, right here.
Yeah, I was
Really loud.
I was wondering, with this research, would you say that eating disorders can be passed down biologically from the mother?
I don't know, and maybe, do you guys know? Okay. Yeah, I don't know. I was trying to think. I guess you'd have to define your eating disorder.
Well, if someone is like bulimic or is like eating an excessive amount of food, and then like with a period of restriction, does that affect like your biology in the same way that you're saying, like malnutrition in a sense?
It's a great question. I don't know the answer to that. I would think that if it did express itself in an eating disorder, it would be bulimia, or the overeating end of things, from what we know from programming. And I would also think, when is this happening? Is this happening in an adolescent, or is it happening in a child? If it hasn't been there during childhood and it appears at an adolescent, I would look at that differently, that's probably not programming, but I do not know, and it's a great question.
Okay, what percentage does the weight-height ratio need to be for the infant to be classified as thin from undernutrition during pregnancy?
I am sure there's data on that, but I do not know that. I would look it up online in the OB-GYN literature, specifically the obstetric literature. I'm sure it's available. I just don't know that.
We have another minute, so who else? Oh, I'll try to get back there too. Yeah, okay. I'll come back here. I'm going to run.
Thank you. You know, I was curious.
Ask your question really loudly.
Thank you. I was curious about maybe the type of birth, you know, like a C-section versus a natural birth. Would there be any impact of that on this topic?
Okay, that is a great question. I have some information on that. It turns out that one of the important things, and I didn't mention this, in terms of our metabolism is our gut microbiome. And we've learned that a baby with a vaginal delivery picks up bacteria from the birth canal, and that's part of what sets up the babies, not only their gut, but other aspects of their body in terms of microbiome. And we also know that in cesarean section that doesn't happen. And I don't know a lot of detail. I can't tell you much about what the differences are, but I wouldn't be surprised if down the line we've gotten so free with probiotics and prebiotics that we'll be making some effort to replace that in the future. But that, as far as I know, that's not happening yet. But it's a great question. It's important. And there may be other things, because everything seems to be sensed by the fetus, you know. So that sensing of pressure, what is that doing? All sorts of questions that go along with that. Thank you.
I'd like to thank Susan Bagby again. Thank you very much. We really appreciate it.